Hi, we're not doing the in-depth Kubernetes Kata integration, but if you want to come to a workshop tomorrow, that's what I'll be doing tomorrow morning. We are doing an introduction to Kata Containers. What is it? Why does it exist? What does it give you? So who's heard of Kata Containers? Good. 2 years ago, that would have been a much slimmer response. Anybody tried it out? Anybody want it back? So anybody, I guess I won't ask if anybody's using it. So we're going to go through what is it, how is it architected, what's the roadmap, how do you get started, what does it integrate into, how would you get to use it. So do you all use containers? So I like this diagram, but I do have to explain it a little. So over here, containers, really fast. Over there, virtual machines, more secure. So Kata Containers, not this one, Kata Containers lives somewhere more over here. It gives you a lot of the security of virtual machines and most of the speed of the containers. So you get, we'll call it the best of both worlds. So, and that's really the basis of Kata Containers. You know, sometimes you want those virtual machines, sometimes you want those containers, but sometimes you want a blend of the two. And how do you use Kata Containers? Where would you deploy it? It's a container runtime, and it looks and feels just like runc, the standard de facto container runtime. And traditionally, we plug it in. Now, for the last 2 to 3 years, container stacks have become much more capable and aware that there isn't just one runtime now. There's probably 5 or 6 I can count. So they've adapted to be able to support multiple runtimes. And Kata drove quite a lot of that backing because we're going, hey guys, you know, every time you release a new version, we have to rewrite our code because there was no API to plug runtimes in. So Kata plugs into Docker, and Docker command line, you can say, you can set the default runtime. So you can say, by default, I want to run Kata. Or you can do it on a command line. Docker, run me this container in a Kata container. Kubernetes, very similar. Tomorrow, if you come along tomorrow, they've just been adapting, learning, basically, how to do this integration of multiple runtimes. So last year, how you did runtimes in Kubernetes was you'd add little tags to your runtimes saying, do I trust it, do I not? But only gives you a black and white 2 runtime choice. Now you can actually tag pods saying, I want to use this runtime or a runtime with these features. So it's much more flexible. And then over on the left, we've got, I think, anybody recognize the dolphin? No. I put that on in Berlin, and everyone was like, what's the, even my own team were like, what's the dolphin? So I think that's the symbol of Zun. So, and we have Zun integration through OpenStack. So you can also use Kata in OpenStack natively as a runtime. Bit of history then. Kata and the forerunners of Kata are fairly old. We could call them mature. So I've been working on Kata for maybe 3 years now, 2.5 years, and it existed about a year before then. But previously, Intel had something called Clear Containers, and a company called SH had something called RunV. And then about 3 years ago, we both ended up in Berlin giving a talk. And it's like, we appear to be talking about the same thing. Okay, and then a year after that, we got together under the OpenStack Foundation, and we formed Kata Containers. And then we blended the best of the 2 code bases. So Kata is the blend of those 2 projects. So the engineers working on Kata have been doing this for 3+ years. And I think Thierry might know. So we're one of the newer projects in OpenStack Foundation that's not OpenStack. And we're thinking Denver, are we having the discussion about promoting to the next tier maybe? Maybe. I think, yeah. So we got into the OpenStack Foundation version 1.0 in May 2018. Version 1.6 was released last week or the week before, I believe. So we are trying to define a nice release process for Kata with a regular cadence. And we do support the last, currently I think it's the last 2 versions with backports of stable bug updates and fixes. So there's a reasonably mature support architecture in place, and that's still growing and becoming more mature. So what is Kata and what does it look like? So traditional containers, you have your process and it's running a namespace and it's got filters and it's got C groups, and then they're all running on the same host with the one kernel. So, and then anybody run containers or container stack in a VM? That's a reasonably popular way of doing, you want some more isolation, you want some customer isolation, then you actually put your stack of containers or your one customer solution into a VM, and then you run that VM on your host, and then you have multiple VMs. But each VM is hosting either a whole stack or a runtime that's got a lot of pods in it. Kata places each individual container. I'll use the phrase container and pod fairly interchangeably. If you're on Docker, it's a container. If you're on Kubernetes, it's probably a pod, which may have one or more containers. So we run each pod inside a VM on the one host. If you can tell you're running your container inside a Kata container, we may have messed up. The whole idea is that it's a transparent, it feels like a container. If there's something that doesn't feel like a container, you can probably open a bug report. And they run individual VMs and they have their own kernels, and you can have a different kernel per pod. Sometimes a customer will come along and say, well, I've got this container, but it relies on a feature from this kernel, or it doesn't work with a newer kernel. You can actually assign, so you could say, I know I need this older kernel for this container, and do that on a per container, per pod basis. So that is the fundamental overview of Kata, is individual containers in VMs that look and feel just like containers. You orchestrate them with the same tools, you manage them with the same tools as you do your containers. And you can even mix and match runtimes. So you can run these beside normal containers. So you can say, well, these containers I trust, or they need specific access to the core system, so I want to run them privileged, and I'll run them in runC. These containers I really don't trust, or I just want to isolate more, I'll run them inside Kata. And that will happen on the same stack, on the same host. So we do a little bit more internal architecture of Kata. How did we do this? What specifically do we have to put together to make this work? So there's a few components. By default, we tend to run QEMU KVM as the VM. And we do optimize a QEMU quite a lot. So QEMU itself, we optimize. We do work with out-of-the-box QEMU as well. So if you have a QEMU on your host, some of the distros, for instance, don't want to carry multiple QEMUs. So we do work with a distro QEMU, but you can get more performance if you choose to install an optimized version. The runtime is like runC, so it's the transitory thing that really is the management. It's given requests to launch this container, exec this command. We have a kernel, we are a VM, we do run a kernel inside that VM, and that has got a rootfs image. The rootfs image, you should probably, most of you will never see. It's like in a container, you never see your host. In this container, you never see the rootfs in the VM. If you can, it's a bug. We have a thing called the agent. Because we're in a VM, we need something inside the VM that manages the container. It needs to be able to set it up and mount things into it. So normally that would be runC does all the work on your host. But we have this, effectively our runC is over on the host, but we have something in the containers in the VM. So our runtime talks to the agent and gives it commands. I want you to start a container. I want you to get the logs back. Shim and proxy, we will cover Shim, I think, is it Shim briefly? I think the proxy's going away. We've managed to do away with a component, which is always a good thing. Basically, if you want a terminal, then you need to be able to tie that in and out of your VM, and the Shim and the proxy are to. And the other interesting trick is, if you're running Docker particularly, Docker expects to have the PID of the actual container, and then when you say to Docker, what resource is it taking? It goes and has a look on the host and says, I'll have a look, it's taking this much. Well, the natural disposition is Kata would hand back the PID of the VM, and then Docker would look at the VM and go, oh, this is your resource. He's like, no, that's not what they're asking. So we actually have a little process in between that we hand So it goes and looks at the proxy, and we basically have to do some magic and get the correct numbers that you expect to see. So when the question's asked on the host, we go, hold on, we're going to ask the VM for the real numbers and pass them back. So this is the visual representation of that. Over here we have the VM with your containers and your exec. You have your kernel. In here, there's actually a mini operating system layer here, the root FS. So you have the agent running inside the root FS. And then the agent uses the same library that runc, so libcontainer, which is really the workhorse of runc. So we actually use libcontainer inside. So effectively, we are running the same container library, the same operations inside the VM as you would normally be running on the host. It's just it's wrapped in this extra virtual machine. So you get this hardware-backed security layer. And then the runtime talks over gRPC to the agent, and the shim does the communication for terminal and some of the logging. And then you have your deployment stacks over on the left. Any questions at that point? Hi.
Can you run Kata containers on bare metal rather than VM?
Can you run, so Kata containers, the question was, can you run Kata on bare metal rather than a VM? Do you mean the host side, or?
Yeah, so we have a bare metal cloud, we don't have VM.
Yeah, so the default position is Kata would run on a bare metal host, and then it would use the VMs for the containers. So I guess the easy answer is yes, that is its natural disposition, is you would run Kata on bare metal. So you'd run, say, OpenStack or Docker on bare metal and then deploy Kata. But it also works, it does also work in VMs. So if you enable nested virtualization. So tomorrow's demo, I'll be doing Kata inside Kubernetes on a Minikube. So Minikube is running in a VM, and then I'll be running Kata inside that, which then runs a VM. So that's a VM in a VM on a host. So yeah, so bare metal is its natural place, but also nested VMs, it works. There's no problem running it in a VM environment. So Kata does work on a number of the cloud deployments, Google, Amazon, Azure, and I think it works both bare metal and if they've enabled nested virtualization, which a lot of the cloud vendors tend to disable. It's effectively a small security hole in their view, but they have got some of their instances you can nest VMs, and then you can run Kata. We run our CI system on 2 cloud providers' machines, and the CI launches Kata containers, so that's running VMs in VMs as part of our CI. Hi.
What's the impact on the networking side of things? Kind of, if any, CNI plugins for the containers?
Yep, I do have one network slide coming up. It's easier now than it used to be. We do have to do a small dance. Traditionally, the VM, if I get this at the right, the VMs would give you a level 2 interface, level 2, level 3, I think, and the might be 3. I have to get this around the right way, and your containers would give you a 3. So there's a 3 and a 2, so it would be a mismatch. So in days of old, we would have to generate ourselves a bridge and then expose those. So you'd have to go through one extra layer. But we've found better methods as we've moved forwards. There's also been work adding, so VMAC, I think, is it, into the kernel, so we can now have the containers, container infrastructure and the VM appear at the same level, and then we can tie them directly together. And then beyond that, we'll get to a diagram or two where you can do direct device assignments. So if you're doing virtualized networking, you can tie them straight in. So the impact's not terrible. So depending on your basic network infrastructure, you may end up with one indirection. And recently we've moved to using TC mirroring, which is a tunneling technique, and that actually costs us a small amount of performance, but it makes us much more compatible with lots of other network interfaces. So we're quite flexible, so you can always, the default will probably work, but you can probably choose a more optimal method if you know exactly what your infrastructure looks like. CRIO, CRIO, I don't know if we call it CRIO. So CRI is the container runtime interface. It's the API that Kubernetes has, and CRIO is the Kubernetes version that adapts to the OCI runtime. Kata is an OCI compliant runtime or compatible runtime. So Kata just drops into the CRIO interfaces, and then you get multiple runtimes appear in Kubernetes. And we work with CIO, and there's an alternative called Containerd. There's sort of two ways of doing this, and it works with both. And then within those, you can fairly naturally choose, do I want to use runc or do I want to use Kata to launch my container? Let the photos happen. Networking and storage. So I guess without any networking or any storage, a container isn't really that useful. You can't get anything into it. You can't get anything out of it. You know, what are you going to do with it? So they're fairly key components of the solution. I think one of my colleagues was hand drawing these on his iPad. Here's how we used to work for the man in the front row. So this is how we used to have basic networking. So we'd have to create a tap and then make a MAC V tap to tie to the VETH pair. And then we've come up with some better solutions. So. And then if you're using DPDK or VPP or one of the software acceleration techniques, then we can hand out a vhost user socket, which then maps directly into that software stack. So you can avoid the extra level of indirection. So we support things like DPDK naturally. And then if you're doing physical networking, so either if you've got a physical NIC you want to hand a container, or you've got SRIOV, so you've got a virtualized NIC, so you have a big NIC you're slicing into pieces, you can directly map those straight into Kata. Kata understands the notion of a hardware handoff or SRIOV. So you can just request that to be assigned to the container. And that works in the same way that you do it in Docker. You sort of assign it and launch the container, and then Kata picks up that you've attached it and then reprograms it to attach to the VM. So, and then hands it back when you quit. Storage. Storage is not quite the bane of our life, but it's getting better. We have a number of ways we can do storage. I'm probably going to start from the bottom and then end up at the more interesting one. Network, Ceph, Gluster, it's just networking. Network works. That's just going to work probably in the way you expect. We have something called NVDIM, non-volatile DIM. We cheat. We pretend to be a non-volatile DIM and then use something called direct mapping. So as part of Kata's launch, we actually direct map some of the images we need directly into Kata, and it's much more efficient. It saves us copying a lot of things across. They share better across all the VMs. This is one of our optimizations. As a user of Kata, you can use this. I'm not sure I've ever seen a customer use it, but you can. If you have a file on your host you want to map straight into memory, you can just request it to be mapped direct through this method. Ideally, we'd use device mapper to hand devices, file systems into Kata. There's some work ongoing at the moment that I think Docker have deprecated device mapper for support. So we're actually working on the most efficient way to map your overlays and your file systems into Kata is through a block device. But not all graph driver backends support that. So you're running overlay 2, then that doesn't present a block device. So there's some work ongoing at the moment to do some LVM-based snapshotters that provide you block mappings. And then if you're not block mapping, the default today is we use a 9PFS file system. And that works in 95% of cases, but it's not the most performant way of mapping files across into a VM. I don't know if we've got Stefan or David in the room, but there's some guys in Red Hat recently did some work, really nice work. They've come up with virtualization. So this is a virtualized file system using the Linux Fuse interface. It's a much more efficient way of mapping host-side file systems into your VM, and we should be deploying that in Kata. They're pushing those changes upstream, so it requires QEMU changes, kernel changes. We're going to carry those patches in Kata for the next version, 1.7, so that we can give that benefit to our clientele before all those patches are landed upstream. So that's a much better way forwards. 9PFS has been around for, well, the third version was called 9P2K. So it's quite mature, shall we say. But yeah, it's time we got something new. So virtualization is a really good thing for us for virtual machine file system mapping to the host. Roadmap. Security and isolation. Kata really is about an extra security layer around your container. So we're doing better and more C groups and namespaces. We're definitely looking at running rootless QEMU on the host. And host-side jailing is something that's come out of the Firecracker project. And we're going to track the upstream for CVEs and exploits more closely. Networking, we just added TC mirroring. It's not currently the default, but in a future version I think it will be. And we're having discussions with a lot of the fabric providers where they're doing container network acceleration by programming things into the host-side kernel. And it's better for us and in some cases for them if we can program that into the VM kernel. File systems, we did virtualization. We're also pushing a block-based device LVM patch up for, I think it's Containerd, so that we can have some better block-based storage with Kubernetes. And other features, Containerd is coming up with a version 2, which due to its hierarchical, its changing model is actually more efficient for us. We can drop one of our components. So the less components we have, the less footprint we have, the less performance overhead we have. And then we're looking at virtual memory, something people are discussing, which is how do you effectively hot plug memory in and out of a container, which is something, you know, if you add a new container to your pod, you want to add some more memory. So more hypervisors. We currently support QEMU. We've added recently Firecracker support. So, and we'll be adding hopefully more hypervisors. I get asked once a month or so, do we run non-Linux workloads? Technically, there's no reason why not. You would have to port the agent into that OS so we could talk to it. Politically is a different matter. So discuss that with your vendor. So, and then we're always looking at performance. As people ask us for more features in Kata, it grows. So we've always got this balance between, well, you want more features, but you want less size. You want it more performant, but you really want it to handle every workload you've got. So that's a constant struggle for us, is to add all the features that people want. We've got a config file that's growing, and people are now starting to complain that the config file is getting quite large. It's like, well, but you asked for all the features, but you wanted the performance, so you've got to turn them on and off somewhere. So that's always an ongoing thing. It's all open source. All of the code's up on GitHub. It's all Apache 2. We have packages, RPM, debs, APK, Snap. Snap's a really easy way to get going. We now have some static binaries you can install in opt and run them from there. And then we have a package up in Clear Linux, which you can just pull down and run. And community, we hang out on Slack quite a lot in IRC. There's a mailing list. And then most of the activities happening on GitHub. So issues, pull requests. And there's a weekly phone conference call, which people can join in. And anyone's welcome. You know, it's come along, listen, give your comments. So the link at the bottom has links to all of those. 5 minutes left, and we're on to questions. Hi.
How tightly are you tied to x86?
We're not. Kata upstream on GitHub also supports ARM, IBM Power 8, and PowerPC, 64 little endian, I think. So yeah, we are architecture and vendor neutral. Hi.
Same spirit. Can you use things like Firecracker, or use something like Firecracker?
Yeah, if you install Kata today, you'll get QEMU and Firecracker. So there is a Kata Firecracker. So we worked very closely, and we're still working very closely with Firecracker guys. So Firecracker, for anybody who doesn't know, is also a very lightweight, small virtual hypervisor. So that's great, because that's exactly what Kata's been trying to do for a number of years. It's so lightweight and tight that it's got a few features that aren't there. So we're working with the Firecracker guys. Part of the block storage LVM work is working with Firecracker, because I think they're heavily 9P based, and that gives you a performance. In their use case for, basically they're doing FAS, function as a service, for Lambda, and I've forgotten the name of their other interface. So Greengrass. So for their FAS workload, it works really well. But if you wanted to deploy other containers, then it's not quite. So it works. There's a few features missing, and it's not as performant on the file systems. So yeah, we're working with Firecracker a lot. So you can try it out today, and it will work for a subset of workload. So anybody else? 2 minutes left, and I look like I'm done. Thank you very much.